Welcome to the Chromperfect user training channel. We are currently working through Section 3, Working with Chromatograms. This section focuses on the tools used to examine and interpret chromatographic data within the analyze environment. In the previous chapter, we explored how Chromperfect controls the visual presentation of chromatograms. We examined the plot properties dialog and learned how labels, colors, drawing elements, fonts, and annotations can be adjusted to customize the way chromatograms are displayed during analysis. These options allow the chromatogram display to be tailored to the needs of the analyst, while leaving the underlying chromatographic data unchanged. We are now starting Chapter 5. In this chapter, we will introduce the fundamentals of peak integration within Chromperfect. Integration is the process used to identify peaks within a chromatogram and calculate the area or height associated with each peak. Before continuing, it is important to note that the detailed theory behind chromatographic integration is already covered in a separate playlist on our YouTube channel. The playlist is titled Chromatography Theory. It covers many topics, but has a section dedicated to peak integration and quantification. It provides an in-depth academic explanation of peak detection, integration algorithms, and quantitative calculations. Within this section, there are 3 videos: Peak Integration and Detection, Integration Timed Events, and Peak Identification and Quantification. If you would like a deeper understanding of the theory behind integration, we recommend watching that series. You can search for these videos on our YouTube channel, and we will also include links to them in the description below. In this chapter, we will focus specifically on how integration is implemented and managed within Chromperfect. It is important to understand that Chromperfect never modifies the underlying detector signal. The raw chromatographic data remains unchanged. Integration parameters simply determine how Chromperfect interprets that signal in order to identify peaks and calculate results. These parameters control how sensitive the peak detection algorithm is when analyzing the chromatogram. Examples include settings such as threshold, peak width, and timed integration events. In Chromperfect, integration parameters are stored within the method file. When a chromatogram is acquired, the method used during acquisition determines how the chromatogram will initially be integrated. If the chromatogram is saved as a bound file, the method used during acquisition is also stored within that file. This ensures that the original integration conditions are preserved and can always be reproduced during analysis. Top tip: users should always use bound files instead of raw files to ensure accurate and reproducible results. This is particularly true when preserving integration settings. If needed, you can re-watch Section 2, Chapter 2, and the video titled The Difference Between Raw Data Files and Bound Data Files. When a chromatogram is opened in the analyze environment, Chromperfect applies the integration parameters from the method to perform automatic peak detection. In this video, we will have a quick look at both manual and automatic changes, which are accessed from the integration menu item within the analysis program. The 3 integration parameters used by Chromperfect are threshold, peak width, and area rejection. They are accessed from the auto option within the integration menu. These parameters control how the software distinguishes real chromatographic peaks from background noise. The threshold setting determines the minimum signal change required for Chromperfect to recognize the start of a peak. Threshold is a dimensionless sensitivity parameter used by the integration algorithm. In Chromperfect, it typically ranges from approximately -24 to +24. Lower values increase the sensitivity of the algorithm and allow smaller peaks to be detected, while higher values reduce sensitivity and help prevent noise from being interpreted as peaks. The peak width parameter provides the algorithm with an estimate of the expected width of chromatographic peaks. This value is specified in seconds and helps the software determine how quickly peaks rise and fall within the signal. If this setting is incorrect, the algorithm may fail to detect narrow peaks or may incorrectly split broader peaks. The area rejection parameter defines the minimum peak area that will be accepted as a valid peak. Very small signals below this value can be ignored to prevent noise from being reported as chromatographic peaks. These parameters may sometimes need to be refined to optimize the performance of the integration algorithm. The objective when adjusting these parameters is to achieve two things. First, to prevent baseline noise from being incorrectly integrated as peaks. And second, to ensure that genuine chromatographic peaks are not missed because the integration settings are too restrictive. A more detailed explanation of how these parameters influence peak detection is covered in the chromatography theory integration playlist mentioned earlier. In some situations, integration behavior may need to change at specific points in the chromatogram. This can be achieved using timed integration events. Timed events allow integration parameters to change at defined retention times. In Chromperfect, these events can be inserted directly on the chromatogram. To add a timed event, select the Insert Event option in the integration menu. Position the cursor at the desired retention time and use the left click followed by a right-click combination to insert the event. This allows integration behavior to be adjusted for a specific region of the chromatogram without affecting the rest of the run. Chromperfect is designed primarily as an automated chromatography data system. The objective should always be to refine the automatic integration parameters so that peaks are detected correctly without the need for manual adjustment. Manual integration tools are available when chromatographic conditions are imperfect or when unusual peak shapes require adjustment. However, manual integration should be used sparingly and should not become part of routine daily analysis. The preferred approach is always to improve the integration parameters within the method and use the necessary timed events so that Chromperfect consistently detects peaks correctly in future runs. It is also important to understand that automatic integration always overwrites manual changes. Automatic integration uses the parameters defined in the method file. Manual adjustments can then be applied afterward to refine individual peaks. However, if the chromatogram is reintegrated automatically, any manual adjustments will be overwritten. For this reason, manual integration should always be performed as the final step when reviewing a chromatogram. If you need to use manual integration, it is very straightforward and uses the same workflow as before. From the integration menu, select Manual and then select the integration type from the dialog. Left-click to perform the change, and then right-click to confirm. A typical workflow when reviewing chromatograms in Chromperfect is as follows. First, the chromatogram is opened and automatic integration is applied using the method parameters. Next, the analyst reviews the detected peaks to determine whether the integration is acceptable. If the peaks are integrated correctly, the results can be accepted. If adjustments are required, the analyst may either refine the integration parameters within the method or apply manual adjustments to the chromatogram. If improved integration parameters are identified, the method can then be updated so that future runs are processed automatically using the improved settings. Understanding how Chromperfect manages integration parameters and how those parameters are stored within the method file is an important step toward producing reliable and reproducible chromatographic results. Congratulations! You have now completed Chapter 5 of Section 3 of the Chromperfect Beginner Training Series. In the next chapter, we will explore how Chromperfect identifies and manages components within the chromatogram and how peaks are associated with compounds during the analysis process. Thank you for watching. If you enjoyed this video, please click the like button, subscribe to our channel, and enable notifications so you are informed when new Chromperfect training videos are released. For more information or to reach out to our team, please visit www.chromatographic.com.